Hi, this is PLSQL, Concept Review Lesson.
SQL Developer tool is used by Oracle and other database vendors to enable users design and code or interact with databases. You can connect to any target Oracle database schema using standard Oracle database authentication. You will use Oracle SQL Developer in this course.
In this lesson, we will use the company schema database. At the end of this lesson, students should be able to understand PLSQL basics, the rule of thumbs on calling functions from SQL expressions, identify how explicit cursors are processed, the handle exceptions, and to use the raise_application_error procedure. An anonymous PLSQL block structure consists of an optional declare section, a mandatory begin-end block, and an optional exception section before the end statement of the main block. A stored program unit has a mandatory header section. This section defines whether the program unit is a function, procedure, or a package, and contains the optional argument list and their modes. A stored program unit also has the other sections mentioned for the anonymous PLSQL block. However, a stored program unit does not have an optional declare section, but it does contain an is section that is mandatory and acts the same as the declare section in an anonymous block. Every PLSQL construct is made from one or more blocks.
A proper naming convention makes the code easier to read and more understandable. It helps you understand the functionality of the identifier. If the code is written using proper naming conventions, you can easily find an error and rectify it. Most importantly, it ensures consistency among the code written by different developers.
A procedure is a named PLSQL block that can accept parameters, sometimes referred to as arguments. Generally, you use a procedure to perform an action. A procedure is compiled and stored in the database as a schema object. Procedures promote reusability and maintainability. Parameters are used to transfer data values to and from the calling environment and the procedure, or subprogram. Parameters are declared in the subprogram header, after the name and before the declaration section for local variables.
Parameters are subject to one of the three parameter passing modes, in, out, or in-out. An in parameter passes a constant value from the calling environment into the procedure. An out parameter passes a value from the procedure to the calling environment. An in-out parameter passes a value from the calling environment to the procedure and a possibly different value from the procedure back to the calling environment using the same parameter. The slide shows an example of procedure creation. The slide shows how to use the created procedure. A function is a named PLSQL block that can accept parameters, be invoked, and return a value. In general, you use a function to compute a value. Functions and procedures are structured alike. A function must return a value to the calling environment, whereas a procedure returns 0 or more values to its calling environment. Like a procedure, a function has a header, a declarative section, an executable section, and an optional exception handling section. A function must have a return clause in the header and at least one return statement in the executable section, and must return a value in each exception handler to avoid the ORA 06503, PLSQL, function returned without value error. Functions can be stored in the database as schema objects for repeated execution. A function that is stored in the database is referred to as a stored function. Functions can also be created on client-side applications. Functions promote reusability and maintainability. When validated, they can be used in any number of applications. If the processing requirements change, only the function must be updated. The slide shows an example how to create a function named get_department_name.
The slide shows an example how to invoke the created function.
A function may also be called as part of a SQL expression or as part of a PL/SQL expression. In the context of a SQL expression, a function must obey specific rules to control side effects. The slide shows the example how to execute function as part of a PLSQL. In a PLSQL expression, the function identifier acts like a variable whose value depends on the parameters passed to it.
There are also another ways to execute functions. It can be executed using a local variable to obtain the result and can be used as parameter to another subprogram as shown in the slide.
The user-defined PLSQL functions that are callable from SQL expressions must meet the requirements as shown in the slide. Be stored in the database. Accept only in parameters with valid SQL data types, not PLSQL-specific types. Return valid SQL data types, not PLSQL-specific types. When calling functions and SQL statements, you must own the function or have the execute privilege. Additional restrictions also apply when a function is called in expressions of SQL statements. In particular, when a function is called from, a select statement cannot contain DML statements. An update or delete statement on a table T cannot query or contain DML on the same table T. SQL statements cannot end transactions, that is, cannot execute commit or rollback operations. Packages are schema objects that groups logically related PLSQL types, variables, and subprograms. A package will have two mandatory parts: package specification, package body or definition. The package specification is the interface to your applications. It declares the public types, variables, constants, exceptions, cursors, and subprograms that are available for use. The package specification may also include pragmas, which are directives to the compiler. The package body defines its own subprograms and must fully implement the subprograms that are declared in the specification part. The package body may also define PLSQL constructs, such as object types, variables, constants, exceptions, and cursors. The syntax for creating package specification is shown in the slide. The OR replace option drops and recreates the package specification. Variables declared in the package specification are initialized to null by default. All constructs declared in a package specification are visible to users who are granted privileges on the package.
The slide shows the syntax for creating a package body. The OR replace option drops and recreates the package body. Identifiers defined in the package body are private and not visible outside the package body. All private constructs must be declared before they are referenced. Public constructs are visible to the package body.
The videos show how to create package specification and package body named employee_sal. With a procedure name get_sal.
The package element consists of variables, procedures and function that can be accessed using the syntax as shown in the slide. You can call a package as a parameter to another subprogram or invoke as part of a PLSQL expression.
A cursor is a pointer to the private memory area allocated by the Oracle server. There are two types of cursors. Implicit cursors, created and managed internally by the Oracle server to process SQL statements. Explicit cursors, explicitly declared by the programmer. The following three commands are used to process an explicit cursor: open, fetch, close. Alternatively, you can also use a cursor for loop. The cursor for loop is a shortcut to process explicit cursors. Implicit open, fetch, exit, and close occur. The record is implicitly declared. Every explicit cursor has the following attributes. Found. Returns true if the last fetch returned a row, returns null before the first fetch from an open cursor, returns false if the last fetch failed to return a row. Isopen. Returns true if the cursor is open, otherwise returns false. Not found. Returns false if the last fetch returned a row, returns null before the first fetch from an open cursor, returns true if the last fetch failed to return a row. Row count. Returns 0 before the first fetch, after every fetch, returns the number of rows fetched so far. The slide shows an example to illustrate the concepts of explicit cursors.
An exception is an error condition during a program execution. An exception can be raised implicitly by the Oracle server, explicitly by the program. An exception can be handled by trapping it with a handler, by propagating it to the calling environment, by trapping and propagating it. This is a flow diagram of handling exception, if the exception is successfully executed. The PLSQL block terminates successfully. Propagating an exception if the exception is raised in the executable section of the block and there is no corresponding exception handler. The PLSQL block terminates with failure and the exception is propagated to an enclosing block or to the calling environment.
Let us write a code to illustrate the concept of exception handling. You can reference predefined Oracle server errors by using its predefined name within the corresponding exception handling routine.
Trapping non-predefined Oracle server errors. Non-predefined exceptions are similar to predefined exceptions, however, they are not defined as PLSQL exceptions in the Oracle server. They are standard Oracle errors. You can create exceptions with standard Oracle errors by using the pragma exception_init function. Trapping user-defined exceptions with PL/SQL, you can define your own exceptions. You define exceptions depending on the requirements of your application. For example, you may prompt the user to enter a department number.
You can use raise application error procedure to issue user-defined error messages from stored subprograms. You can report errors to your application and avoid returning unhandled exceptions. Is used in two places. Executable section exception section returns error conditions to the user in a manner consistent with other Oracle server errors. The slide shows an example of user-defined exceptions handling. The DBMS_output package sends textual messages from any PLSQL block into a buffer in the database. You can use set server output on to display messages. By default, this feature is turned off.
The procedures provided by the DBMS_output package include: put to append text from the procedure to the current line of the line output buffer. New _line to place an end-of-line marker in the output buffer. Put _line to combine the action of put and new _line, to trim leading spaces. Get _line to retrieve the current line from the buffer into a procedure variable. Get _lines to retrieve an array of lines into a procedure array variable. Enable / disable to enable or disable calls to the DBMS_output procedures.
In this lesson, we have learned PLSQL basics. Rule of thumbs on calling functions from SQL expressions. Identify how explicit cursors are processed. Handle exceptions. And use the raise_application_error procedure.